boys went to the Cubs game. Let's see, I guess it was a different day by now. All right, let's look at the notion of domain next. So first objective was piecewise functions, and our next objective is taking a look at domain issues. Objective B is domain. Okay. In domain, we have three main issues. The first issue is, the domain of a function is going to be all real numbers, everything from negative infinity to infinity, unless you run into one of the three following problems. And just to help you retain this, studies have shown that students learn math a little bit better when there's music playing in the background. And well, the definitive study on music and mathematics was done with three groups. And this music, by the way, is from an album called Fresh Air 1 by Mannheim Steamroller. And I can pull the volume up on that just a little bit. But students learn math in three groups in the study on music and math. In group 1, students had no music while they were learning. Group 2, students had classical music, music that was moving along at about 1 beat per second. And in group 3, students were learning with heavy metal music going in the background. Well, when the students were tested, the students who performed the best were the ones who had classical music going in the background. They didn't really specify why. There's different ideas on that. Guess who came in second place? Yeah, it was the students who had no music. It is possible for things to go wrong when you have music playing in the background, so it can be distracting. Hopefully this will enhance your receptivity to mathematical knowledge. So here we go. There's three issues that you run into when you're finding domain. It's not always going to be the set of real numbers. One is radicals. If you have a variable expression under a radical, then the domain restriction comes from setting that variable expression greater than or equal to 0. The variable expression has to be greater than or equal to 0. A second restriction on domain occurs when you have variables in the denominator, like if you have 4 over a variable expression. Then to find the domain, you have to declare that the variable expression cannot be equal to 0. Otherwise we have division by 0, which is undefined. And the third restriction on domains occurs when you have a variable expression as an input to a log function. We're going to take a whole chapter studying logarithmic and exponential functions. So if you're feeling a little shaky on logs, don't worry, we'll get that straightened out later. But if you have a variable expression in here, do you recall what type of number that variable expression has to be? To find the domain, you would take the variable expression and say that it has to be positive. The variable expression must be positive. So let's do an example of this. Example 1 under domain. What is the domain of the function f of x equals 7 divided by the square root of x minus 4 times 3 minus x? Well, if you look at this, the domain cannot be all real numbers because we have two restrictions on the domain, one caused by the radical and another caused by the variable expression in the denominator. So we're going to write x minus 4 times 3 minus x must be greater than 0. Now, had this radical been in the numerator, I would have said greater than or equal to 0. But since it's in the denominator, I also honor the restriction that the variable expression cannot be equal to 0. So I pull off the bar, goodbye bar, and I have to solve this. Now this is the sort of thing that was that you've seen recently. And as you'll see when you get the Chapter 1 assessment back on Monday, I did take off points. If you did not label your axis, not much use to have a point. But also if you did not show me what was going on with how you calculated these values. I mean, we have boundary points at 3 and 4. Orange may not be showing up. I realize sometimes it's hard to see orange. I'm going to pull back on this and go back to blue. So I've got boundary points at 4 and at 3. And what I'm looking for here is a recognition that you see the leading coefficient, the quadratic coefficient, is going to be negative. If you don't believe it, FOIL this out, use the FOIL method. So I would expect to see negative, positive, negative up here. I'm interested in when these x values are positive, greater than 0, so I'm going to shade, open circle, shade, open circle. The domain is a very small domain. X is an element of the set 3, 4. And using interval notation, I would have to put parentheses around the 3 and the 4. So there's a domain. X is an element of the set 3 to 4. So let's move on to just a few examples similar to what you'll encounter on the homework. Okay, so this will be example 2. I'm going to pull this out of the textbook. And actually first, you know what? I'd like to look at some of the quick sketches that you're responsible for at this point. If you take a look at the list of quick sketches that you printed out at the beginning of the year, some of you did that for extra credit, go ahead and pull out your list of 48 or 49 quick sketches. I think maybe it's 48 and a half sketches. Take those out. I want you to know which ones you're responsible for on the next test. You are responsible for quick sketches 1 through 8, 13, and 14. So what that means is that I believe the first quick sketch is y equals x. And I'm just going to pull up my website real quick just so we can see exactly what those are. On the 48 quick sketches, I'm just going to pull up the quick sketch equations. See if these open. All right, so I must have a zoom in on this. Just zoom in. Yeah. So the quick sketches are 1 through 8, 13 and 14. So 13 is a circle, 14 is the upper semicircle. So just make sure that you can sketch these faster than just doing point plotting. And I'll give you an example of what I would expect. Like for example, number 6, the 1 over x graph. If you were sketching number 6, a quick sketch would have labeled axes. The 1 over x graph has 2 branches. It's actually called the hyperbola. One branch in quadrant 1, a branch in quadrant 3. I would expect you to put a couple of key points on here, like this is point 1, comma 1. F of x equals 1 over x. And you would not get full credit for this graph unless you include the asymptotes. There's an